Hi, my name is John. Welcome to another SMC technical training video. In this video, we will show you how to hook up an Ethernet IP EX600 with digital inputs and outputs. During the video, we will show you the equipment, parts, and software that you will need and show you how to set everything up. In the end, we will have functioning I/O and actuators controlled by the PLC through the EX600. Let's get started. Here are the tools, parts, and part numbers that you will need to set up the digital I/O. You'll need a PC, software, and Ethernet connectivity for communication as well. Please complete the EX600 hardware, IP address, and generic Ethernet module setup videos first. Then check out the EX600 analog module setup video. First, we will hook up specific discrete input and output components to the EX600. You will need this wiring diagram in order to connect the I/O through the D-sub DMPE. So that the discrete I/O can communicate with the EX600, we will use this adapter with an e-stop relay for safety. Reroute the 24-volt DC power through the e-stop relay. Wire the normally open start button to terminal 1, which is input 0, and the normally closed stop button to the terminal 2, which is input 1. Verify by checking the LEDs on the DMPE module. Now, to receive signals from the cylinder's auto switches, we connect them to 24 volts and to inputs 4 and 5. With air off, hook up the tubing from a valve to the actuator we want to monitor. Now, turn air on and verify pneumatically by using the manual overrides. To adjust the auto switches, slide them into the actuator grooves and move them until the light turns on when the cylinder is in the proper position. Verify connection with the DMPE module lights. Wire the photo eye components and again verify with the module lights. Now, wire the flow switch before connecting its tubing. Connect the flow switch to the valve output that we want to monitor. Set the flow switch output to 60 liters per minute. With source air on, manually override the valve station and gradually open up the speed control. The output LED on the flow switch should turn on at 60 liters per minute. Next, wire the green indicator light output as well. Finally, make sure the actuator is plumbed up. Now, let's monitor the discrete I/O. Open up the EX600 web monitor and enter as an admin. Click on the DMPE module for digital I/O. Pushing the Start button shows up as green on input 0. To see the outputs, click on Out 0-7. Notice none of them are on because we've not started the PLC. To test the light output, go to Force Mode. Turn output 0 on. Notice the background is yellow now. The light should be on. Before leaving this screen, remove the force by clicking Reset. Open up the PLC program, and if you go to Controller Tags, you will see that we already have our data mapped for the EX600. Specifically, we're dealing with the digital inputs and outputs. Those are going to be the first byte of input and of output. That's actually these bits here, and these bits up here. So now we will first create aliases for the inputs and map the solenoid bits to match. Begin with the Start push button. Select input data 0, bit 0, give it a name and then an alias. Then go and create a rung for I/O test. To do that, go to the main program, go to the main routine. First, we create a dummy bit for an output called I/O test. Right-click on it, select New, and create. Then, on the same routine rung, start putting in the rest of the inputs. For example, on the first one, begin to type Start, and it will fill in the blank for the Start push button that was already created. Below that, you will also see the alias bit associated with it. Now, add the names of the remaining inputs for the program. Then add the outputs. So, right-click on the stop, create New, and under this tab, tell it to create an alias for that. Go to the pull-down and read EX600 inputs, data, byte 0, and notice that bit 0 is grayed out because it is already associated with the Start push button. Select bit 1 and create. Now we can see that the Stop push button was added to the rung just like the Start push button. Do the same thing with the photo eye. Then add the flow switch. Next, the Extend limit switch. And finally, the Retract limit switch. Now let's set up the outputs. First, add the green light output as before. The air supplies are actually solenoid valves. So this is going to be an output and land in byte 5. Then add the second air supply. Now add the actuator extend, and then the actuator retract. Finally, add the clamping cylinder as well. Now, as the rung items are blue, we see that the inputs and outputs have been accepted for the program. Make sure to check out the items on the rung that are showing as on and running, then save the program. Next, run Who Active from the Communications tab. Now, download the application into the PLC. Next, press the Start button. We see the input signal here on the rung. Now, press the Stop button. If you put your hand in front of the photo I-beam, we see that motion here too. To activate the flow switch bit, toggle the output bit to the valve controlling its air supply. Then adjust the speed control until the flow switch reads 60 liters per minute. Then the flow switch input bit should turn on. To move the actuator, we need to turn on the extend output. Toggle the bit to extend the stroke, and then again to turn off that bit. To return the actuator, we need to turn on the retract output. Next, we can adjust the clamp output. Notice how it changes from the extend to retract limit switch by toggling the clamp bit. Now you are ready to write your own program to control these digital inputs and outputs for an application. We hope you found this video useful. Look for other SMC technical training videos to assist you in learning about and using our other automation products.